So, dear students, in this video, I'll start explaining the Unit 1 concepts. That is basically we are going to discuss about the casting process. So, as my previous video, I have explained about the different manufacturing processes that are casting, forming and shaping, machining and joining. These are the four fundamental manufacturing processes. The first and foremost manufacturing process, what I would like to discuss in today's video is casting. So basically, casting is a process in which we actually melt the metal into a liquid state, and then we will try to pour it into a cavity where it will actually get solidified and take the shape of the cavity. And later we can remove all the other things and finally get the part of desired shape. So, in order to understand this whole process, we need to learn about certain things here, like what is meant by cope, what is meant by the drag, and what is the green sand, how it will be useful for making this mold cavity. And there are some technical terms like runner, in which the molten metal is poured, and now how it go into inside this cavity, what is meant by a core, and what is the function of a riser like this. There are so many things which we will discuss as we go on. So initially, let us first start discussing about what is the process of casting. So this process involves basically the molten metal which flows by gravity or by force into a mold, and where it solidifies into the shape of the mold cavity. The part made by this process is called casting. So here you can see one example figure of a large sand casting which is weighing over 680 kgs. It is being manufactured for an air compressor frame. This is more. This whole thing was manufactured by using a casting process. So when this process is originated and where it originated, if you look into that details, so we can say that it was there way ahead of all the processes, that is way back in 3000 BC in Mesopotamia. We can see the traces of uh, casting process being used by the ancient Mesopotamians. And then there is a history regarding the uh, uh, records of casting process being utilized in China in 1500 BC, and in Indus Valley civilization around 1000 years BC. This particular process, casting process, was used. And one of the examples what we can cite that India also used this particular process. Here we can see the Qutub Minar pillar, which is standing tall till now, which was made in 375 AD. So still, there is no rust formation on this particular pillar. So that is the beauty of the casting process. And coming to the casting, a variety of casting methods are available, and thus makes this is one of the most versatile manufacturing processes of all. And the parts made by the casting process range from very small component to very large components. So earlier I have shown you a very large component weighing up to 680 kg. So casting can also be used on other materials such as polymers and ceramics. So this is the basic understanding of what are the things that are required to be known when we actually enter into study the casting process. So here you can see this is the parting joint. I have explained about the cope. Cope is the upper part and the drag is the lower part. So these two will be joining at this parting joint. And generally, this particular parting will be made in such a way that the cavity is symmetrically distributed onto the both sides of the cope and drag. And the function of the riser is actually to whatever the pouring basin is there. Here we pour the liquid molten metal into this one. So this flows through the gate into the pattern, and whatever excess is there, it actually enters into the riser. So this part is known as a sprue pouring basin. So here we'll actually pour the molten metal, and it passes through this gate and enters into this pattern area, where actually it will create a cavity. So this cavity will be filled with this particular molten metal, and after solidification, we can remove all the scope, drag, and other things so as to produce the actual component. So this is the technology that is used. Drag is nothing but the lower molding flask. Scope is the upper, and the pattern is nothing but a replica of the final object that is to be made. So parting line means the dividing line between the cope and drag. So this is another schematic which shows how the molten metal actually enters into the cavity, and then what are the other things which are there. So here you can see this is known as a sprue. This is the runner, molding cavity. This is the core, and here you can see whenever the molten metal is poured here, so there are vent holes provided so that we can actually show a provision for the exhaust gases to come out of that one. So because this whole process involves a lot of heat, so dissipation of those gases is very much required. Otherwise, it will produce some kind of defects. So this is another thing like core. Core is nothing but the one which will be used to create hollow components. Like if you want a through hole, then what you can do is you can keep a core here. The molten metal cannot enter into this area, thus producing the hole inside that. So other technology like pouring basin is the one is a small funnel shaped cavity on the top, and the sprue means it passes through the molten metal, that is known as sprue. And runner is the one which will actually in the parting line which will be there, and which will facilitate the molten metal flow and regulates it before it actually reaches the mold cavity. And there is something like gate, the actual entry point of the molten metal into the mold cavity. So we can use chills and chaplets. So these are all used for supporting the cores, which are actually used for creating cavities. And riser is nothing but the reservoir of molten metal. So this will actually allow the hot metal, whichever is actually flowing, it can go back to the mold whenever there is a reduction in the volume because of the solidification. So these are all the some of the technology, and this is cope, this is drag, and what is meant by core you can see here, and how the core is supported by chaplets also illustrated in this diagram. So these are the steps in sand casting. So basically, first any casting process starts with the preparation of the mold, and you need to pour the molten metal into the sand mold, and then allow it for to solidify, and then you have to break the mold and remove the casting and clean it and inspect it, and whatever the gating system, reservoir riser system are there, you need to separate all that, and maybe sometimes heat treatment process is required so that we can get the required properties, metallurgical properties for the casting. So these are the 6 steps: preparation of the mold, pouring of the molten metal, and we should allow that to solidify for certain times, and then break the mold, take the part and clean it, and then if required we'll do the heat. So this particular sand casting process is again it is indicated with the help of this diagram. You can see here, first it starts with the pattern making. As I said, pattern is the replica of the part which we are going to manufacture. So when we make this pattern, this will be used for making the mold. So when you are making the mold, we so definitely need sand and preparation of the sand. Any sand doesn't work, so we need to prepare the sand so that it will have the properties to withstand that high temperature and whatever the weight is there. So it should not collapse. And here, when you are making a mold, sometimes the core is also required if you need any cavities inside the that particular part. And here, after making the mold cavity ready, what you need to do is you have to take the raw material, that is the iron, melt it, and then pour it, and then you allow it to solidify. And finally, you have to remove that particular mold, sand mold, and cleaning of that particular part will be done. And finally, finishing will be done. So this is the total process that is followed for the sand casting. So there are so many steps again to discuss in detail. That is, first thing is patterns. How do we make those patterns? And then how do we make the cores? And how do we prepare the mold? And how do we actually melt the uh, material, and how do we pour it? What is the methodology that is followed for the cleaning? So these are all the basic steps that are there. One by one, we need to go on discuss about each and everything. So in the next video, we'll be talking about the patterns, how the patterns are made, what are the different types of patterns, and we'll enter into the other parts of uh, the casting, that is molding, core making, the melting process, and the cleaning process. So I'll stop this video here, and the pattern making will be continued in the next.